Virtual memory has introduced some of the advantages, and along with that we have to manage many things. I mean, virtual memory is not that simple to implement. See, the main concept is this. If you have, I'll better take the diagram and explain you. If you have the main memory, and main memory is going to contain many frames, and if you have many processes, let us say process P1, process P2, process P3, process P4, like this. If I have many processes and I have main memory, then the main task of virtual memory is to see that a part of every process or a part of as many processes as possible will be present in the main memory, right? Then why should we do that? The reason is to increase the degree of multi-programming, and once we increase the degree of multi-programming, then CPU utilization is going to increase. So the entire purpose of virtual memory is to see that, as of now, initially it was proposed to run a bigger process in smaller memory, but as of now all the computers are using virtual memory for this, to see that as many processes are present in the main memory as possible. But then we are not going to put the entire process in the main memory. If we do that, we will not be able to accommodate many processes, right? Now in that case, the main thing is there are various things here, right? So if there is no concept of virtual memory, there is no problem at all. The entire process will be present in the main memory and we can run it till completion, and when we don't want it, we will move it out and then get the other process. That is fine. But now when we have these many processes which are all competing for a common resource, shared resource, which is main memory, how are you going to see that everyone will get a chance, a fair chance, right? So for that reason, we have to talk about two things. Mainly in virtual memory, we have to talk about two things. Virtual memory implementation. One thing is frame allocation. And other thing is page replacement. So what is frame allocation is, when we have these many frames and these many processes, how many frames will you really allow each process to sit in and run? That is the frame allocation. And then the page replacement is, once we allocate the frames to the process and now the pages are in the frames, right? Are you getting it? And now once the pages are in the frames, and when we need a new page which is not already in the main memory, then it cannot use a new frame. If its quota is over, let us say the quota of each one is 4 frames, and already they are using 4 pages in the 4 frames. Now when they need the 5th page, which one are you going to replace? And that decision is going to have significant impact on the performance. See, both these two algorithms, this frame allocation and page replacement, is going to have significant impact on the system performance. The reason is, if you allocate very few frames for a process which requires lots of frames, then there will be something called as trashing. Trashing means, you might, for every instruction there will be a page fault. The page will not be present in the main memory. Then you have to go to the main secondary memory and get it. So the overall execution time for an instruction or for a program, in fact, is going to increase. So both of this. And page replacement, if you don't do the replacement well, if you are replacing continuously the frequently used pages, then what happens? Frequently will get the page fault, right? Then these two algorithms have to be designed so well in order to improve the performance of the system. Now the main challenge is this: how are you going to decide how many frames are you going to allocate to a process? And let's see, how should we be guided with this? I mean, what are the basics to start with? One thing is, whenever you try to allocate a number of frames to a process, right, there is something called as minimum requirement. So what is minimum requirement is, depending on the architecture of your CPU or the processor, or your entire architecture, you might have some instructions, and in order to run one instruction, we might need, let us say 4 pages. So in order to complete one instruction, if we need 4 pages, how do we require 4 pages in order to run one instruction? Maybe it might so happen that an instruction has to be fetched See, let us say one instruction is there. In order to fetch the instruction, we have to go into a page in which the code is present. Therefore, one page is required from the coding part, that code segment part. Okay. One page is required from the code segment part, and let us say it is having two operands, and two operands are present in two data pages. Then two pages are required from the data segment part, and let us say it is implementing even a function call, and therefore we might even make use of a stack. The result has to be pushed onto a stack, right? Then one stack page. Then in this scenario, one instruction, in order to finish, it needs all the 4 pages. Now if we don't dedicate four frames, then all the 4 pages will not be present in the main memory at the same time. Now let us say you have given it only 3 frames. Now this instruction has been fetched and the data has been computed, and when it is trying to save the result onto the stack, then there is a page fault. And you know what? Whenever there is a page fault during the execution of an instruction, the instruction has to restart again. Then what happens? There will be a page fault for this stack page, and therefore there will be a page replacement. Assume that you have replaced this one now, right? Code page. And again when you restart the instruction from the beginning, which means when you try to fetch the instruction, again there will be a page fault because code page is not there. Now what you do? Again you replace this stack page with the code page, right? Then what happens? Again you start the everything, and again it will keep on happening, right? Therefore, for every instruction, if there is a page fault, then that concept is called as crashing. So if you don't design everything well, there will be a lot of crashing. Crashing means for every instruction, almost for every instruction, if there is a page fault, then the program execution time is going to increase exponentially. That is called as crashing. Now in order to decrease the crashing, you should keep track of everything. So one thing is there is minimum requirement. And what about the maximum requirement? The maximum requirement of any process is size of the process itself. If the size of the process is 100 pages, then how many size of the process, if the size of the process is 100 pages, then how many frames are required? 100 frames, right? So there is always some requirement which is defined by the architecture, and the maximum requirement is defined by the process size. Now you have to choose a number between these two. You should not give less than this minimum because the program will never get completed, and you should not give more than maximum because it is not required, right? And then you have to choose something in the middle. Why can't we go for the maximum requirement? Because if you go for the maximum requirement, we will not be able to allocate the frames to other process as well. We want to keep that degree of multi-programming also as high as possible. Got it? So what happened is, now people did this. They have, between this minimum and maximum, we are supposed to choose some number and allocate them to the process. Then what people did is, they have come up with some strategies. One strategy is equal allocation. Equal allocation, and other strategy is weighted allocation. And the other strategy is dynamic allocation, right? So we shall see about each one. Equal allocation is nothing but like this. If you have, let us say 30 frames, and when we have 3 processes, right, then 30 by 3 is how much? 10. So we allocate 10 frames to each process. This is called equal allocation. And weighted allocation means, see, giving equal number of frames to every process doesn't make sense. The reason is, some of the process might be small and they might not need those many frames, and some of the frames might be really big. Some of the process might be really big and they might need more frames. For example, let us say in these 3 processes, one process has 10 frames, and other process has 100 frames, and other process has 1000 pages. 10 pages, 100 pages, and 1000 pages. In this case, what happens is, when you give this equal allocation to all the frames, it doesn't make sense, isn't it? For a process which needs 1000 pages, giving it 10 and for a process which reads only 10 pages, giving it 10 doesn't really make sense. So in that case, what they say is go for weighted allocation. Weighted allocation means depending on the size of the process, we are going to allocate it some frames. Let us say size of the I'm just talking about some example. Let us say size of one process is 20 pages, and size of other processes is 30 pages, and size of other process is 70 pages, right? Then what is the total requirement? 20 plus 30 plus, let us say 50, and the total number of frames available is 10 frames, right? Process P1 is having 20, process P2 is having 30, and process P3 is having 50 pages, and the total number of frames I have is 10. Then I don't want to go for equal allocation. If I go for equal allocation, what I should be doing is I should actually give maybe 3 3 3 to all of them, right? But then I don't want to do that. I want to give more number of frames for a process whose size is big. Then what I do is I do something called as weighted allocation. So for that reason, I'll add up the total requirement. What is the total requirement? 20 plus 30 plus 50, which is 100 pages, right? And then depending on the weight of each one, requirement of each one, I am going to dedicate it. So I have 10 frames. This is the total requirement and this is the total availability. Now in the numerator, I am going to change the numbers of these requirements, which means for P1, how many do I allocate? 20 by 10 into this much, right? Then how many will it get? It will get 2 frames, right? And for P2, how many do we get? 30 by total, which is 100 is the requirement into 10. Then P2 will get 3 frames, right? And what about P3? P3 will get 50 by 100 into 10, which means 5 frames, right? So 2, 3 and 5 are the allocated frames to each process. Now this allocation is depending on the size of each one, right? That is why it is called as weighted allocation. So if you want to see the formula which is guiding this weighted allocation, in this weighted allocation thing, it looks like this. Let us say the size of each process is process Pi is Si. The size of process Pi is Si. Then I'll try to find out the total need. Total need, let us say capital S. Total need is the total sizes of all the processes. How do I calculate? If there are n processes which are where n is the degree of multi-programming, which means we want to run all these processes simultaneously, then I'll find out what is the total need. And once I find out the total need, then what I try to do is I go for the weighted allocation. So let us say the total number of frames available is capital F. Capital F is total number of frames allocated. Then the number of processes, then the number of frames process Pi will get is Si divided by capital S. Capital S means total need into capital F, where F is total number of frames. This is called weighted allocation, right? So using this method, I can fix some number of frames for each process, and then I can run the process only in those frames, right? And what happens is at any particular time, any process can have the number of pages, maximum number of pages which can be present in the main memory will be equal to the number of frames allocated to it. Not much more than that, right? So these two methods are actually static. Static means once I allocate the frames like that, I'll not change, right? And then the other thing is we have something called as dynamic method. So what we do in dynamic method is we don't fix up the frames like that. We allow a process to grow and shrink as it executes, right? So we allocate something called as priorities, and now depending on the priorities, I'll start off all the processes with whatever page they want, let us say 1 page each. Now if a process with higher priority wants more frames, then it could forcefully replace the pages of the process with lower priority, right? For example, let us say there are 4 frames like this, right? and initially P1 process P1 is executing in 2 frames and process P2 is executing in 2 frames. That is what I started with. Then in case if process P1 needs more frames, and if process P1 is having higher priority compared to process P2, then process P1 can pull out this frame and it can expand, right? So this is called as dynamic allocation, right? So there have been various methods possible and various things, all of them are successfully used in many operating systems, right? But there are some problems as well. Okay, we shall see that how does this each one turn out to be, right? And then page replacement algorithms. So once we decide about the number of frames which have to be allocated to each one, and once we allocate those many frames, sometimes what happens is a process will use up all the frames allocated to it, and it might need to load a new page. Let us say a process got 4 frames and it has used up all the 4 frames and it has filled it up with 4 pages like this. It has used up all the 4 frames and it has filled up with page number 1, page number 2, page number 3 and page number 4, and let us say it is static allocation, which means it is not supposed to use beyond 4 frames. Then what happens is, if it wants one more frame P5, right, then which one are you going to replace? That is called as page replacement algorithm. And even the page replacement algorithm has to be very careful. Otherwise what happens is, let us say P1 is in P1 has been in use for a long time and it is frequently being used. Now when in order to get P5, if you replace P1 and you get P5, right, then the chances are that next time P1 might be again referred, right? There is something called as locality of reference, right? Okay, we shall see that later, don't get it here. Okay, so to keep this thing simple, what I mean to say is, when we want to replace a page, and make this space for the other page, which one are you going to choose? Which one is going to be the victim, right? Now depending on your choice, the system performance is going to vary, right? So that is all called as page replacement algorithms. And again, page replacement algorithms are also of 2 types. One is local and other is global. So local page replacement algorithm means, once it works for static allocation. Static allocation means, once a process has been decided and given 4 frames, then whenever you try to replace any page for that particular process, we replace only from the 4 frames. For example, what I mean to say is, there are 2 types of algorithms. One is local and other is global. Let us say this is the main memory, and in main memory we have various frames, right? And assume that the first 4 frames, frame number 0, frame number 1, frame number 2, frame number 3, these are allocated to the process P1, right? And all the other frames are allocated to some other process, and maybe you could even assume that they are not being used currently. As of now we are not using them, right? Or they may be allocated to some other process P2, right? So what does the local algorithms do is, always when let us say process P1 is using this page 1, page 2, frame 1, frame 2, frame 3, frame 4, and all of them are currently under use, and now it wants to load a new page, right? Then local algorithms will only replace the pages which are allocated to the process, which means they will not look for any other frames for the replacement. They will look for only the frames which are allocated to P1 for the replacement. So how does local algorithms work? The local algorithms work in such a way that whenever we have to replace any page, then we are going to replace the page only from the frames which are allocated to that particular process. We will not disturb any other process, right? Then what about global is? Global is quite different. So if it has to replace a page, then it will consider everything for replacement. From all the available frames, it can replace anything, and it can use many parameters, like it can see which one is having least priority, or it can see which process has been allocated some memory and which is not using it at all. So depending on various parameters, global will work. But then mostly local are preferred compared to global. The reason is, I know global doesn't always help us in increasing the performance. In the sense, I'll just tell you this. I'll just take an example and I'll just tell you. See, assume that we are having a process, and a process is having high priority, and the process priority is very high, right? And we are using global allocation, right? And for the process to run, in order to execute each instruction, let us say it requires 10 frames, and if you have completely 9 frames, right? We have only 9 frames in the main memory, but then it requires 10 frames constantly in order to finish the program. All the 10 frames have to be present so that it can finish up. If the 10 frames are not present, it will keep on crashing, right? Then what happens is, even if this high priority process starts with 1 page, or let us say 2 pages, it is present in these 2 pages, and all the remaining pages are allocated to some other process and they are running well. Now what will this try to do is, since it is of high priority, it will try to take up the frames from all the others, right? Therefore all the other processes will have to run in less number of frames, and therefore they will crash, and even this one will also keep crashing, because even if it takes up everything, then also it will not be able to run completely without crashing. So global algorithms are a bit problematic, right? So anyway, what we do is, there is a solution for crashing. We shall see it later. But most of the algorithms which are generally used now are local algorithms. Now we shall see what are all the algorithms, page replacement algorithms used. So in your exam, in the GATE exam, if they don't mention anything, assume that it is local algorithm, because local algorithms are practically used. Global algorithms are not really practically used in most of the operating systems, right? So if they don't mention anything about the kind of replacement used, always go for local replacement. Local replacement means they will say that a process has been reserved 4 frames and so algorithm is used for replacement. Then when you are considering a page for replacement, think that we have only 4 frames to work on that and not more than that. Got it? So we are going to discuss only about the local algorithms, not about the global algorithms. And then one part which I have to teach you is how to solve the crashing. Crashing means whatever you do, there will be some sequence or some process which might need lots of frames, otherwise it will keep on crashing. Then how can we solve the crashing? So we shall see that later, but for now let's now focus on the local page replacement policies. I hope that you understood this, right? So there are 2 issues. One is frame allocation. Frame allocation means how many frames are you going to give to each process to run, and second is, once you allocate the frames, they are not obviously going to be sufficient to load the entire process, and therefore at any point of time, this process will keep on asking for more pages. Then which page are you going to replace? That is called page replacement algorithms, and these 2 decisions have to be very careful, otherwise the system performance is going to degrade, right? And second concept is, there is something called as demand paging. Demand paging means we are not going to load any page in a frame until it is required. Okay, see this. So assume that there is a process, and for that you have decided that we are going to give 4 frames. There is a process and you have decided that we are going to give 4 frames. Frame 0, frame 1, frame 2, frame 3. Even when you give 4 frames to a process, and when you initially start running it, all the frames will be purely empty. That is called as demand paging. So demand paging means we will not load any page unless it is asked for. So now without any pages in the main memory, we start the process, and the instruction pointer will start with the main program. Now even the main program page is also not present in the frames at all. Therefore initially your process is going to generate page fault. Then page number 1 will be loaded some page number, right? And then page number 2, page number 3, page number 4. Therefore there will be page faults initially until all the frames are full. And once the frames are full, then if the next reference is for one of the frames which is present in the main memory, then there will be no page fault. In case if the next reference is for a page which is not present in the main memory, then there will be a page fault, right? So in all the questions, normally we use demand paging concept. Demand paging concept means we assume that initially nothing is present in the frames allocated, and we start from that assumption, and whenever any page is being asked for, we load it. So why do we go for demand paging is, we cannot anticipate what is the request that will be made by the process. Therefore it is better that we start off with nothing, and in case if it asks for any page, then in that case I'll load a page, otherwise I'll not load it, right? So since I cannot anticipate the request that will be, Demand paging is the best thing because I cannot anticipate what is the request that will be made by the process. Understood this? So what the main concept is, we are going to have frame allocation, which is going to be given in the question. They'll say that a process is allocated so and so number of frames, and then they'll say that we are going to use this kind of page replacement policy, right? And then they'll say that this is being used. Demand paging is not being used. Demand paging is being used means start with the assumption that there is nothing in the main memory, and then they'll ask you, in order to complete this process, how many page faults are required, something like this. Okay. And one other concept which is opposite to this demand paging is called as pre-paging. Pre-paging means we can start a process. Before starting a process, we load all the frames given to this with some process. Are you understanding it? So we are going to have two things here. One thing is demand paging. Before starting the process, we are not going to allocate anything to that, right? And another thing is pre-paging. Pre-paging means before starting the process, all the frames which are being allocated to that process will be filled with the pages, right? And then there is one more concept called as reference string. Reference string is CPU is going to generate some sequence of addresses during the execution of a process, right? So they will give you something called as reference string. Reference string. So reference string is CPU is going to generate some number of some addresses, right? So that is what they are going to give. So they will say that CPU, in order to execute this process, is going to need these many pages and in this particular order. Now that is called as reference string. And given that reference string and all these concepts like how many frames are allocated and what is the page replacement policy and what is whether it is demand paging or not, you are supposed to find out how many page faults will be there. So these are the most frequently asked questions. For example, reference string of a process can look like this. They may say that reference string of a process is 0, 1, 4, 5, 7, 1, 6, 7, something like this. So what they mean is CPU first needs the page number 0 and then needs the page number 1 and then need the page number 4, 5, 7 in this order. So if this is the request generated by CPU in this order, then how are you going to how many page faults will your strategy generate? What is the strategy? Frame allocation, page replacement and demand paging, if these are used. But whatever it is, they are going to mention everything specifically in the question, and these questions are very easy and very scoring. We shall solve all of them. I'll explain you about the algorithms first, and then at the algorithms we shall solve questions. Okay, fine.